Okay, in this next video we're going to look at problem number 1 in the problem 91, in the problem set that deals with shadow length. And here we have a man who is 5 feet tall, who is walking at a rate of 3 feet per second away from a light that is 16 feet above the ground. Now the fact that the man is walking away from the light post means if we were to look at this problem superimposed on an xy coordinate plane, that his x coordinate is increasing, and the rate of the increase of his x coordinate is 3 feet per second, something like we have in the diagram here. Alright, now what we want to see is when the man is 10 feet from the base of the light, we want to find the rate that the tip of the shadow is moving and the rate that the length of his shadow is changing. And so the light shines down over the man's head and makes a shadow on the ground. And if we label the man's position away from the light post to be x, then the position from the man to the tip of his shadow we will label s. And so we have this quantity x plus s, which identifies the distance between the light pole and the tip of the shadow. Alright, so what we're trying to find here is the rate of the rate that the tip of the shadow is moving. And in this case we could identify that as the rate of change with respect to time of x plus s. And that is just dx dt plus ds dt, differentiating both sides, differentiating with respect to time. And we do know what dx dt is, that's 3 feet per second. And in this problem we're going to have to try to find what ds dt is, which happens to be the answer to part B here, which asks for the rate that the length of the shadow is changing. And we want to find the rate that the length of the shadow is changing, and also that the tip of the shadow is moving when he's 10 feet from the base of the light. That is when x is equal to 10. We're going to have to differentiate before we plug in, of course. Now we need some kind of formula to relate dx dt and ds dt, and we're going to use the system of similar triangles and the proportion that they give us. And that leaves us with the proportion 5 is to 16 as s is to s plus x. We multiply both sides, so cross multiply here. We get 5s plus 5x equals 16s, or 5s is equal to 11s. Sorry, that's 5x is equal to 11s. And solving for x, or in this case, since we're trying to find ds dt, let's solve for s. And this will be, since that has all of the, when we differentiate with respect to time, that will have all the rates that we need in it. And so we differentiate implicitly, and we end up with ds dt is equal to 5/11 dx dt. We know that dx dt is 3, and so the rate that the shadow is changing is 15/11 feet per second. That's the answer to problem A. That's the answer to problem B, rather. And for part A, we need to find dx dt plus ds dt. And that then is 3 plus 15/11, which turns out to be 48/11 feet per second. And as I said, that's the answer. That is the answer to part A. That is the tip that the shadow is moving, as opposed to that is the rate at which the tip of the shadow is moving, as opposed to the rate at which the shadow is changing length. So that is problem number 91. And the answer then is, for that one, is D. Okay, so that should do it.